All right, pre-cal, we are starting Unit 3. What's Unit 3? Rational functions. Yay! The fun never ends. Okay, so what are we going to look at first? Well, the first thing I want you to do is notice that we are solving rational equations. So all of the problems I'm about to do will have an equal sign in them, and we will be solving for x. So the first thing you need to recognize is that if something can factor, you need to factor it, whether it's in the numerator or the denominator. You need to note any domain restrictions. Remember, we cannot divide by 0, so if there's an x in the denominator, we need to figure out what values x cannot be. And then, of course, we're going to identify the LCD. We are going to then multiply every term in our equation by our LCD because our goal is to get rid of any and all fractions that may occur because that's going to make solving so much easier. Okay, so having said all of that, if you will look at number 1, and we did this in class today, but I want to go back through it with you. There's no factoring I can do, and there's no x in the denominator, so I'm just going to start with my LCD is 6 because it needs to contain a 2 and a 3. So that's why I chose 6. So I'm going to take x over 2 plus x over 3 equals 7. I am going to multiply every single term by a 6. So that gives me 6x over 2 plus 6x over 3 equals 42. And then, of course, these will reduce. So I've got 3x, got 2x, and I end up with 5x equals 42, so x just equals 42 over 5. Easy peasy lemon squeezy. Okay, I'm going to do the same thing on number 2. There's nothing to factor. There's no x in the denominator, so I jump right to my LCD. It is also 6, so I'm going to take my equation here, and I'm going to multiply every term in the equation by 6. So that leaves me with, oops, get rid of that. I wrote that wrong. That leaves me with 6x plus 6. That has to distribute over 2. 6 times 2 is 12 over 3, and then 6x. Okay, we want to reduce. 2 goes into 6 3 times, so both of those will reduce. And by the way, the 2 has to go into both of those evenly in order for that to work, in order for us to get rid of our fractions. So now we end up with 3x plus 7 equals 6x. I subtract 3x from both sides. I end up with 7 equals 3x. And then, of course, I divide both sides by 3, and x equals 7/3. Okay, excellent. All right, so as I move through here, now we're going to look at a little bit different situation because now we do have in our denominator something that has a variable. So go back to your list of instructions here, your list of steps. Factor everything that can be factored. Well, there's nothing here that will factor, but the next step tells me to look for domain restrictions. So these will occur anytime there's an x in the denominator. So that means that I'm going to look at x minus 5 because it's in the denominator. Well, a value for x that would make this 0 would be a 5 because 5 minus 5 is 0. So that means that we do have a restriction here. So x cannot be 5. So there's my domain restriction. You can write it as simple as that. I wrote it with a little more flair today, but you can write it that way. Okay, so I'm going to have 1 over 1 plus 5 over x minus 5 equals 2x minus 5 over x minus 5. I am multiplying everything by the LCD. What is the LCD? Well, it's x minus 5 because that's what's in my denominators. So I'm going to multiply every single term by x minus 5. So 1 times x minus 5 is x minus 5 plus this 5 right here. And then I'm going to put x minus 5 in parentheses because remember the goal of doing this is to eliminate our fractions. And if the numerator and denominator are not reducing in a way that totally eliminates the denominator, then we haven't done our job. So I've got 2x minus 5 times x minus 5 over x minus 5. Okay, so now I am going to do some magic reducing here. So I've got x minus 5 plus 5 equals, those go away, 2x minus 5. All right, negative 5 plus 5 is 0. And then if I subtract 2x from both sides, I end up with a negative x equals negative 5 and x equals 5. Well, we already talked about the fact that x can't be 5, so there is no solution to this problem. And don't freak out about that. That just means that if we were to graph this function, if we were to set it equal to 0 and graph for it, it wouldn't cross the x-axis. That's all that means. So, no big deal. Okay, number 4 is a doozy. It's so much of a doozy that we're going to switch colors. It's that serious, kids. Okay, so step 1, we're going to factor. Step 2, we're going to look for domain restrictions. Then we're going to identify the LCD, multiply every term, solve, and list extraneous solutions. Okay, so oh, by the way, we could have done that on 3. All right, this is an extraneous solution right here. Okay, so on this one now, we do have the option to factor. So I am going to look at every single numerator and every single denominator. This numerator won't factor, this numerator won't factor, this won't factor. X squared plus 2x will factor. We can factor out an x, and then this will factor. We can factor out an x again, and then this will factor. Okay, so now what we have to do is we have to look at our domain restrictions. So that is the very first thing I'm going to do. If you'll notice, the denominator, I've got an x here and an x here. Well, it's the same x, so I'm going to set that x equal to 0. Okay, so guess what? X can't be 0 because if x is 0, see, it gets multiplied by this term and this term, and that would make my whole denominator 0. So x cannot equal a 0. Okay, now I'm going to take my x plus 2. Okay, x can't equal negative 2. Now I'm going to take my x plus 1. Okay, x can't equal negative 1. Now, we have an x plus 2 over here and an x plus 1 over here, but we've already taken care of those right here. So my 3 restrictions, x can't be 0, x can't be negative 2, x can't be negative 1. All right, so let's identify our LCD. Our LCD has to contain every single item that is available to us in each denominator. But if something is present in one denominator and another denominator, it only has to be present in the LCD once. Let me show you what I'm talking about. Notice that this denominator has an x and this denominator has an x. Well, since neither one of them have 2 single x's, I just need the one x. Okay, my denominator also, my denominator also has to have an x plus 2 and an x plus 1. So here's what we're going to do. We're going to look at all of our denominators and we're going to make sure that our LCD is covered. All right, so this denominator has an x. There's that x. It's got an x plus 2. There's the x plus 2. It's got this x. We've already got the x. It's got an x plus 1. So we've got the x plus 1 right here. And then we're going to check this denominator, x plus 2, x plus 2, x plus 1, x plus 1. So we've got everything that we need here. So that's awesome. All right, so now what we're going to do is we're going to go back to our original problem. I'm going to rewrite this. This problem takes a long time. Sorry, babies. Okay, so here's our original problem. Remember, I'm going to multiply everything by the LCD. This is going to take a while to write out, but it will help you to do that. So here's what we're going to do. We're going to multiply all of this. We're going to distribute it to every single term. All right, so I'm just going to start writing it out. I've got x times x plus 2 times x plus 1. All of this gets multiplied to x plus 1. So I'm going to have another x plus 1 here. Minus, I'm going to have x times x plus 2 times x plus 1 times x plus 4. This is all over x times x plus 2. This is all over x times x plus 1. It equals x times x plus 2 times x plus 1 times negative 3. I'm running out of room. Times x plus 2, or sorry, over x plus 2 times x plus 1. Now we get to start crossing things out. Let's use another color. All right, so the x's go away. The x plus 2 goes away. The x goes away. The x plus 1 goes away. X plus 2, x plus 1. That is exactly what you want to see in this situation. You want to see all of your denominators crossed out. All right, so what do we have left? Well, up here, we've got x squared plus x plus x plus 1 minus, use parentheses here because you've got to distribute the negative. You've got x plus 2 times x plus 4, so that's x squared plus 2x plus 4x plus 8 equals x times negative 3, so negative 3x. All right, now I'm going to tidy this up a little bit and combine like terms. And now I'm going to distribute this negative here. Okay, I'm going to combine like terms again. X squared and negative x squared add to 0. 2x and negative 6x give me negative 4x. 1 and negative 8 give me negative 7. And now I'm going to add 4x to both sides. I've got negative 7 equal to 1x. So x equals negative 7, and negative 7 is not one of our restricted values, so there's our solution. See, it only took like 30 minutes. No problem, kids. Okay, we'll do the other examples in the next video.